Hello, and welcome to the second law of thermodynamics, as explained by Maria Aiura. Here's a little bit of information about the second law of thermodynamics. It deals with something called spontaneity, or how spontaneous a process is, whether it occurs all by itself, and how much energy must be supplied for a reaction that isn't spontaneous to occur. Some spontaneous processes are iron rusting, ball rolling down a hill, ice melting, a lot of stuff like that. Which of the following processes do you think are spontaneous? Let's look at the first one. A rock rolling uphill. Does this happen in everyday life? No. You'd have to push or pull the rock to get up the hill because it's not going to happen all its own. Leaf falling, on the other hand, that happens all the time. Just gravity pulls them from the branch to the ground, so that is a spontaneous process. And water boiling at 100 degrees Celsius. If you heated it to 100 degrees and turn off the heat, is it going to start boiling? No, it's not spontaneous. You'd have to keep putting heat energy into the water to get it to start boiling. Some processes are more spontaneous than others. Entropy measures just how much disorder or randomness is in a system at a given moment. So when you want to measure how the reactants of a reaction, how their entropy or randomness compares to the products of a reaction, to see how the system changes in entropy, you would compare their two S values and come up with delta S. This is a mistake. It's supposed to say S goes up. So when disorder increases, S goes up. Entropy or disorder or randomness goes up as the reaction proceeds, so delta S would then be positive. An example of a delta S positive reaction would be just something as simple as dumping matches out of a box, because they're orderly when they're in the box, but they're all scattered everywhere when you dump them out. So the net amount of disorder or randomness in that system of the matchbox is a lot larger once the reaction has occurred. On the other hand, when disorder decreases in a reaction such as taking the matches off the table and putting them back neatly into the box, the amount of disorder goes down because order goes up. You have a double negative there. Since disorder goes down, the system becomes more orderly, so delta S is a negative value there. Another question, another quiz. When delta H of the reaction, which is change in enthalpy, is negative, that means that the reaction loses energy to become less energetic. When delta S reaction is negative, what is that telling us? Well, going back to what we just talked about, we know that delta S is the change in entropy for a system as a reaction goes to completion. So when that's negative, what does that mean? That means that disorder is going down, because the change is a negative value. That means that disorder is going down. That is telling us that the products have less disorder than the reactants, or more order, so that the system is becoming more ordered and having less entropy. Does disorder increase or decrease with the formation of gaseous water? We're going to try and explain our answer using the diagrams. So let's look at the one on the left. The gray molecules are O2, there's 3 of them, and the white molecules are H2, there's 1, 2, 3, 4, 5, 6 of them. And on the right, we have, after all those molecules have reacted, that's what we have on the right, we have 1, 2, 3, 4, 5, 6 molecules of H2O. And when a reaction, this is the general rule, when a reaction results in a decrease in number of particles, the amount of disorder goes down. Therefore, entropy decreases and delta S is negative. You can just think about it as like having a lot of mess on a table and then like sorting everything, all the little pieces of things that are on the table into like 3 boxes. That would be disorder going down. And that would be the amount of quote-unquote particles on the table going down. So that's another analogy you can think of. Indicate for each of the following processes whether delta S will be positive or negative, and explain. Alright, let's look at the first one. An ice cube melting. Is delta S going to be positive or negative? So